Okay, guys, sorry for getting this out to you so late. Let's take a look at the stuff for inverses. So whether you realize it or not, you guys have been doing inverses for a long time. Every time you solve an equation, you use an inverse operation. So if I look at these, there are a series of check marks down the side of this, and I need you guys to do all of these check marks with me. So for instance, the first one has 5 points right here. And we're going to plot those 5 points on our graph. That's the first check mark. So we're going to go to 2, 3, plot that, and so on. So I'm just going to hit pause while I plot all those, and you guys can do the same. And then hit play again when you're ready. Okay, so you can see that I plotted my 5 points, and then the next check mark says take this line that's already drawn on there and label it. So this is a line y equals x. And basically that line represents whatever you plug in for x is going to be the equivalent value for y. So if you go anywhere, like if I go to 4 on my x-axis, then the y value is also 4. Interchange, the next one says interchange all your x and y values. So interchange means to take, for instance, this one's going to become 3, 2. The next one's going to be -2, -5. And you're not changing any of the signs, you're just changing the order of them. So 4, -1, 1, -9, and the last one would be 6, 1. And then plot those new points on your axis as well. So we're going to hit pause, we're going to plot those points, and then we're going to compare what the old points and the new points look like. So hit pause and plot your point. Okay, so if you look and you notice, what you should see, now I did the first ones in purple and the interchanged ones in green. And so what most of you will tend to notice is that, like, let's look for example here and here, these points are a mirror image of one another, but they're not your typical line of symmetry because they don't flip right over the y-axis or right over the x-axis. In fact, they flip over this line right here, this y equals x line. So if I fold along that line, then my points then match up with one another. So there is symmetry, but it's just a different weird kind of symmetry that we're not used to. So those that we just saw, those are called inverses. So if I look at this new set, this is the set called h of x. And we're going to use this notation now. So h, and with that little -1, that stands for inverse. So we're going to figure out what h inverse of x means. So if I see that little -1 symbol, I know that that means that I'm going to be interchanging my x and my y values. So to do the inverse of h here, we're just going to take 3, -1 and make it -1, 3, and make it 2, -7, and 5, -4, and 6, 0. Now you might be thinking, like, that's super easy. What does that mean? So basically an inverse, when you normally plug in an x, it gives you a y value. Well, the inverse's job is to take you from basically what you finish with and work you backwards to what you started with. So let's get rid of that. And so it takes the answer and reverses the process. So in the case of this first ordered pair, -1 would have been the answer to me plugging in 3. In this case of the inverse, I start with the answer, so I start with -1 here, and it gets me back to what I started with at 3. Okay, so we're going to find a series of equations now that basically give us what those inverse equations are. So think about, like, if I take, I'm going to just make one up. Let's say I take an equation like f of x equals 3x minus 5 all divided by 4. And I know if I plug in the number 1, it's going to give me some answer. I would do 3 times 1, get my answer to that, subtract 5, and then divide it by 4. So I'd get -2 divided by 4, and I would get -1/2. Smartboard isn't working. Oh, great. There we go. So like I said, you get 3 times 1 first. That gives you 3. You subtract your 2 or your 5, and you get -2, and then you divide it by 4. If I'm dealing with the inverse, which is going to have that little symbol, that would say I'm going to start at -1/2. And I have to figure out the equation to work my way backwards so that I end up with what I started with, which was a 1. Okay, and over here to the left are the steps that are going to help us accomplish that. So if you look at those steps, you're going to, first of all, get rid of this type of fancy notation for just a few minutes. Then we'll plug in a y instead of f of x. And then we have to interchange our x and y, just like what we were doing before. And then the biggest job is solving for that equation. And then we replace y back with fancy f inverse notation. Okay? And I'm actually going to start with 2 and not number 1, and then we'll come back to it because of the fraction. So if I look at number 2, and I sometimes like to make a little cheat sheet, kind of like what I did before when I made up that problem. So if I take an x in this case and I plug in a number, first thing I'm going to do is multiply it by 2. Then I would subtract 5, and then I would divide by 7. Why do I make that little cheat sheet? Because it helps me figure out what I need to do for the inverse. So basically, for the inverse, I'm going to start at the bottom of that list, and I have to undo this thing first. So I'm going to undo that dividing by 7 by multiplying by 7. And then I'm going to undo that subtracting 5 by adding 5. And so we're going to use all those steps that we've used in the past to solve equations, and we're going to use that to find an inverse equation. Okay? So first thing we do, if you look at those steps, is we're going to trade y instead of f of x. So it's going to be y equals 2x minus 5 all divided by 7. And then you have to switch your x and your y. So we're literally just going to make this the x and this guy up here the y. Okay, now we're going to put these steps that we talked about up here into play. So first thing I'm going to get rid of is I'm going to multiply both sides by 7. And the purpose of doing that is to cancel out that 7 that's on the bottom. So now I have 7x equals 2y minus 5. So that took care of this step. And now I'm going to likewise add my 5 to the other side. So it's now going to then build this side up as I tear down the other side. So I have 7x plus 5 now equals 2y. So again, now we've taken care of that plus 5. And last but not least, we have to divide everything over here by 2. And so when we do that, we get the equation y equals 7x plus 5 all divided by 2. So replacing and putting back our fancy notation instead of this, our equation is going to be f inverse of x equals 7x, well, not sure what happened there, plus 5 all divided by 2. And you can ignore that weird black line. Okay, so this is our, oh, man, so that's our equation. Okay, without the black crazy lines. Moving back to number 1, the one that has this fraction thing going on. So first thing we're going to do is make this y equals and keep everything else as is. So you want to get rid of function notation, make it back to equation notation. Then we're going to make this the y, this the x. Leave everything else as is. Okay? If you need to make a cheat sheet list like we did over here for what's happening to the variable, if you were originally plugging in a number, then do it. Okay? So looking at my equation, first thing I'm going to get rid of is plus 1. So then I have my equation right now stands at x minus 1 equals negative 1/3 of y. And so to finish that off, to undo negative 1/3 as a multiplier, we can multiply by -3. And over here, since it has 2 parts, you have to put parentheses around that to show that the whole thing has to multiply by -3. So you have -3 times the product, or the sum of x minus 1 equals y. And we put our fancy notation back instead of y, so we get f inverse of x equals -3 times x minus 1. And that's your equation. Sorry, this is bothering me. I gotta fix this. This is making me crazy. All right, let's try this again. So that should be 7. Holy crap. X plus 5. Let's do a couple more. So again, there's your directions. If I look at this one and I make my cheat sheet for my X, starting with my X, first thing I do is square root it. And then I subtract 10. So if I'm in undoing mode, I have to get rid of this one first. So this is my cheat sheet for my inverse. And so I'm going to add 10 first, and then whatever's there, I'm going to square it. So that's each one of those get rid of my steps. So let's go over here, change our y equals notation. Okay, so we've got our y equals, make a trade, make this x, make this y. Everything else stays put. Now we're going to undo, get rid of that 10. So we're going to take our x plus 10 over here, square root our y, get rid of squaring something or square rooting something by squaring it. Put some hugs around that first though. So now you've got square root. God, why don't I keep saying square root instead of square? X plus 10 quantity squared equals y. And we're almost finished, but we just got to put our function notation back in. So x plus 10 all squared. Okay, hit pause, try the next one. If you're super confused, then obviously just walk through it. I'm going to do it step by step, but hit pause and try to do it on your own. So switching, switch my variables again. Then I'm going to start undoing. First, I'm going to add 10. Sorry if you can hear my dog being a baby. X plus 10 equals 5, y to the third. Next thing you do is divide by 5. You've got to get your exponent and variable alone. So you have y to the third equals x plus 10 all over 5. Then to undo this cube power, you would cube root it. And that means the cube root has to go over the whole other side as well. So now you've got your f inverse of x equals big old cube root over the whole x plus 10 divided by 5. The only other thing that you could do is split the x and the 10 away from each other and do x over 5 plus 10 over 5 and reduce that to a 2 if you want. Okay, the last part, which tends to be the issue for most of you guys, is reliant on this. I give you two equations already, or two functions, and I ask you if the two of them are inverses. To figure out if that's the case or not, you have to do two compositions. Your job is to do f of g, plug it in, and g of f, and if everything cancels out and they are composition, or they are inverses, everything's going to cancel out and you just get an x and stuff. Okay, so I'm going to do that composition. We're probably going to run short on time, so I'm going to kind of just set some of this up and not walk a lot through it because I only have like 1 minute left. Okay, the first one you can say this interval is f of g. Now we have to go back through and do this other one. And technically, I should probably just stop and share something with you. See how when I plugged it in, I didn't get everything to cancel out. This simplifying gave me an x, but I have this extra 12. So this one, I don't even have to do this one. I already know right here that these two are not inverses. Okay, so let me show you just kind of start to finish on this one. So if we do g of f, I'm going to take g, which is negative 15 plus 4, all divided by 3. And I'm going to plug in my other function, negative 3x minus 2 up here. And then I start simplifying. So this gives me negative 15 minus 12x minus